So this is the start of Chapter 2, which is called Radical Functions. So in particular, 2.1 is called Radical Functions and Transformations. So we've just spent a whole chapter on transformations, and so let's just talk about what a radical function is. The basic one we're going to start with is y equals the square root of x. So for the function y equals square root of x, we can look at a table of values or at a graph. Your graphing calculator will help you with either of these. But if we put in some numbers, for example, the square root of 0 is 0, so this graph is going to have a point at the origin. The square root of 1 is 1, so not seeing too much of the shape so far. But as you start to get to larger numbers of x, the square root of 4, for example, is 2, so the point 42 is on the graph. Just to stick with nice numbers that will give us good answers, the square root of 9 is 3, so 0.93, 5, 6, 7, 8, 9, 3, and etc. 16, 4, and you can go on and on. The curve, if you connect these with a smooth curve, or if you plot it on your graphing calculator, looks something like this. The domain and range of this curve are, the domain is x. X can be any number greater or equal to 0. You can't square root any negative numbers, so that's your domain. Your range actually turns out to be the same, because y, being the positive square root of x, is going to be greater or equal to 0 as well. So, being that this section is called Radical Functions and Transformations, let's try a couple of transformations of this function. The two simple transformations I've chosen to start off with are these two equations here. The first one, y equals the square root of x plus 5, all under the square root. The second one, y equals the square root of x minus 3, where the minus 3 isn't under the square root. If you go back to the rules that you've learned all through Chapter 1, hopefully you'll agree that this first one is going to result in a horizontal translation 5 units to the left. So I'm going to take the graph we've already drawn above and move it 5 to the left, and you can see exactly that on your graphing calculator. Looking at the graph above, you'll see same shape, same size, just a graph that's been moved 5 units to the left. So no big surprises. You could do a table of values to prove it to yourself, but it's going to be a radical function, a square root function that's been moved 5 units to the left. So this coordinate here, -5, 0, where the original had one at the origin, which was 0, 0. The second one that we'll call, so I suppose I should label this one A on the graph. The second one that we'll call B is just going to be a vertical translation of 3 units down. So if we take the original radical function and move it 3 units down, we'll have our result. And so what you'll find is you'll get a graph that has, again, the same shape, same size, same overall curve, but it's been moved down 3 from the original square root function. So I'll label that one B. And the last thing we'll do is talk about their domains and ranges. For the one that moved 5 to the left, x now can be anything greater or equal to -5. The range hasn't changed. We didn't move up or down or do anything vertically to this graph, so it's still y is greater or equal to 0. Sorry, I did my less than sign instead of the greater than sign, which is what I've told you not to do. In the second one, for graph B, the domain is back to where it originally was, which is just x has to be greater or equal to 0. But in this case, because I moved the graph down, the range did change, and so y is now greater or equal to -3.